When we build artificial intelligence today, we often build crowds. The standard approach is the multi-agent system, a sprawling, ever-expanding network of AI actors designed to talk to each other to solve problems. We have mirrored the human organizational chart in code. These systems assume that a distinct population of retrieval agents, reasoning agents, and execution agents must permanently exist, passing messages back and forth across virtual departments. That permanent structure creates measurable friction. Agents sit idle waiting for dependencies. They spend computing power managing communication drag. Once an artificial agent exists, it may even generate unnecessary tasks, like excessive verification or routing, simply to justify its active state. Inheriting human bureaucratic structures compromises the speed and logic of artificial intelligence. Conventional orchestration assumes these agents are already sitting at their desks, and the only question left is how to divide up the day's tasks among them. The alternative is to let the requirements of the work dictate whether an actor exists at all. Dr. Wesley Shu defines this as the energetic paradigm. This system is designed specifically to govern the existence of capabilities, rather than to coordinate a fixed population of agents. Flipping the hierarchy ensures that computation is spent solely on solving the problem, not on maintaining the system's staff. Under this framework, the system treats a workflow as an energy map that measures the exact gap between the current state and the target state. Before assigning work, the system maps the current state, the target state, and the barrier between them. Identifying this gap triggers action. An execution tool materializes directly at the barrier, appearing strictly because the condition requires a precise capability to bridge it. The system treats this summoned capability as a temporary execution structure, bound strictly by a state transition contract. Once the barrier is cleared, the contract ends. The execution tool dissolves back into nothingness. The workflow actively cleans up its own architecture. Because generation and dissolution are tightly governed, every ounce of computational energy goes directly toward reaching the target state. There is zero idle overhead. But creation is only half the equation. The system also employs authority governance. When an agent is summoned, it receives only the absolute minimum permissions required to fulfill its specific contract. If it is summoned to analyze a file, it cannot execute a command. Strict verification conditions run alongside it to ensure the temporary structure cannot overstep its narrow mandate or alter the broader system. This precision extends to human operators too. The standard safety model assumes we need a permanent human in the loop, sitting at a dashboard to monitor everything. The energetic paradigm uses energy-triggered human participation. A person is called into the workflow only when the risk, moral consequence, or uncertainty breaches predefined automated safety thresholds. Tying system authority directly to the conditions of a problem, rather than granting it permanently to a fixed identity, inherently limits the risks of runaway autonomous systems. This framework moves the focus from finding an existing agent to asking if a capability should exist. By discarding rigid departments and idle workers, the AI remains adaptive, shifting its execution architecture to match the evolving contours of the data. Treating the persistence of an unnecessary agent as a direct operational hazard prevents the slow creep of institutional bloat and unchecked autonomy. Building systems around the governance of capability existence creates an environment where capabilities arise, execute, and vanish, exactly as the state transition requires.